going to talk about something that I have been working in the last 4 years. As Dayana said before, I'm now based in Spain, but in the last 5 years, I have been working as an assistant professor in Aarhus University in Denmark. Aarhus University is the largest civil uh, has the largest civil engineering program in Denmark. So it's a big university. And I worked in the Department of Civil and Architectural Engineering, so we were a big department. And we are going to talk today about why it's important to understand construction workers' distribution of time on job site. So this title presentation is quite different about what Dayana sent to you about the use of wearable devices, but it's exactly the same. So, but maybe I changed a little bit the topic to narrow to workers' distribution of time, but it's about the use of wearable devices. So let's start with answering this question: why is it important to understand construction workers' distribution of time? Well, let me. This figure is quite blurry, but don't worry. The next figures they are going to be better than this. So it's important to understand workers' distribution because it's not the same if our workers spend most of their time in production activities or in preparation activities. And this is going to be very different if independent of the kind of process that we are studying. But in general, thinking, having in mind our lean construction philosophy of mind, all of us, we want that our workers spend most of their time in production activities. And if you are not familiar with this idea of which is preparation, which is production, or which is non-value adding activities, we need to remind the transformation value theory from Koskela in 1992, which is that now we are not going to see. I know that some of you are familiar with this theory, but just to have in mind and for refresh your minds. So production in the past was seen as just transformation activities or transformation inputs into outputs. But more than 30 years ago, the Professor Lauri Koskela from Finland developed a theory that we cannot see production in the construction industry, just transformation. Production is more than this. We need to consider production as a combination of three kinds of activities, which is obviously the transformation, the activities that add value, the flow, which is also the flow of materials, that are part of the process, and also the value, which are the cost, which is what the clients or the customers are required. And if we think in any kind of process of an industrial process, we can divide it all the activities, or we can classify all the activities into 4 kind of activities. And we can see here in this figure, here, that we have 4 very popular symbols or icons, which is that all the process can be divided into storage, transport, transformation, and inspection. So if you think in any construction process, all the activities can be classified into one of those. So we can see production is a flow of materials and information from raw material to the final product. So having this in mind, the only activity that add value to the client is the transformation, which is when we transform a material into something else. It can be into a new product, or it can be in a secondary product or a sub-product. So in order to make our process more efficient, we need to reduce the number of steps or reduce to the number of activities that do not add value to the process. So it means that we need to reduce the number of storage, transportation, and inspection activities, and try to maximize our transformation activities. So try to spend as much as we can in transformation activities. So, and how we understand or how we can see how much time we spend in transformation activities, and transformational activities are important because the client of our products is at the end is going to buy square meters, or is going to buy something that we have developed or transformed. He's not going to pay for the number of transportation activities that we did in our job sites, at the number of inspections that we did. At the end, he's asking how much or how many square meters did you produce in the last week, not how many inspections or how many transportation. And this is why it is important to understand how much time we spend in transformation. And in the lean construction philosophy, we understand transformation as the activity that add value and the others do not add value. So having this in mind, some researchers have developed techniques to understand how much time we spend in those kind of activities, in transformation and the other kind of activities. And one of the most famous technique is the work sampling technique. Work sampling technique is also called, it has been called in a different ways. In Portuguese, we say amostragem do trabalho, but there is a lot of, all of them have the same base, which is a random observation method that we're trying to determine the percentage of occurrence of certain activities by a statistical sampling random observation. Involves taking a small portion of sample of occurrences in the overall activity. So I'm going to explain with my own words what this means. You are in the job site, you identify a process, and you are trying to see how much time the workers spend in doing this kind of process. Imagine that they are doing the application of a mortar in a wall. How much time of their time I spend in applying the mortar? They are transporting the mortar bags on the job site. How much time they are looking for the measuring? How much time? So this is, and then if we take as much a number of samples as we can, then we can say that the number of samples is going to represent how it happens every time in the job site. So which are the main steps for having or making a work sampling? So the first thing that we need to do is to establish the construction process of the study. So which is the construction process that we are going to study? It's going to be the mortar projection, it's going to be the pouring of the concrete, it's going to be the installation of the windows. We need to define which is the process that we are going to study. Then we are going to clarify the categories. So we can classify our categories in any kind of classification, but in general, we try to see which is production, which is preparation, and which is waste, which is the activity that does not add value. And then having those main three activities, we can go into more details. We can have a breakdown structure of which is preparation, which kind of preparation is transportation, is measurement, is small, is stocking, or which kind. It can be more detailed. It can be as detailed as you want. Then we need to develop the data collection forms for sampling. In the past, when I started to do the work sampling, like it was like in 2012, like 13 years ago, I did manually. So I have my paper sheet, and I went to the job site and I started to mark the number of observations that I did in every single activity of one specific process. Then, obviously, now with the devices and with the advance of the technology, we can have more advanced data collection forms. In the last years, we have used Excel spreadsheet for making the record. Then we need to select the confidence interval. So we want to say, okay, we are not going to record which is happening in the job site, but at the end we are going to try to see if we have an entire record of the 8 hours of working, how much time of those hours they are spending on production, on preparation, on other kind of activities. But it depends of the number of samples that you are going to collect, that your sample is going to have a different confidence interval. Is not going to be the same if you have observed the workers in 20 times or if you have observed the workers in 2,000 times. So the more the largest sample, it will be more accuracy, obviously, but at some points you don't need to collect more samples because it's not going to change. So you need to define which is the number of observations that you need to take for represent what is actually happening, but it's not that you need to take an observation every single second, because in that case it will be easier to make a record. So you need to calculate the number of observations needed. Then you need to collect the data. So you need to actually go to the job site and make the collection. And then you need to summarize the results and make the analysis according to the purpose of your study or whatever. So continuing to clarifying the categories. So the most famous is, as I said before, is production, preparation, and waste. But as I said, it can be divided into more specific categories, and this is what we call breakdown discrimination or breakdown structure. For example, imagine that we want to be very specific. We can make several categories inside the preparation. Everything that is preparation is when you are placing the material in the final place or when you are transforming the material. So, for example, imagine that it was the process of a carpentry process, so is when someone is installing, and here you can see in this image here that everything regarding installing is going to be production. Everything regarding cutting, removing, cleaning, or preparing tools is going to be preparation. But also in this case, we use it other categories as talking, transport, walking, and waiting. So in green, we can see production, which is what's the activity that add value. In yellow, the activities that do not add value but are necessary for the process, and in red we have the waste. In this case, we consider waiting and walking as a kind of waste. And for example, we can have here like a waste is waiting for material, or waiting for a coworker, or waiting without any known purpose. Okay, so now we have make the categories that we are going to study. Then we need to collect the data. Here we can see some images when I was collecting data in one job site in Denmark, and those are the six main categories that we use it. And in this case, we use it an iPad for making the collection. So every time that we saw a worker, we identified what kind of categories they were doing. It was preparation, transport, and then we have it's just a counter. And then you have, okay, I have observed 20 observation out of 100. So 20% of their time they were doing preparation. I observed 50 times doing walking. So 50% of the time they were doing walking. So you can say if they have 8 hours of work, they were walking 4 hours, for example. And this is how it works. And this is just a content. And this is how it works, the work sampling techniques. It's a screenshot of, you need to say what you are seeing in that specific moment and register. Okay. And then with the data that you're going to collect, you can make different kind of analysis. You can try to see in an 8 hours of work how much they spend their time, but also you can see in which hours of the day they spend more time in preparation or in transport. For example, you can see that at the beginning of a day they are spending more time in transportation, and then in the middle of the day they are more productive and they are spend more time in production. So this is what generally the work sampling technique has been doing in the last 20 years. But that technique or that way of making the work sampling has been very criticized for several reasons, but some of them are is because it's just a snapshot. So it's just what you have is what you are seeing in that specific moment, but it can be different in another moments, or if you are or in another days, because it changes a lot. Because you know that the construction job site is a environment that changes every day. So maybe what you are seeing one day is going to be different from another. And also it's also criticized because we can interrupt, maybe the observer is interrupting the workflow. So you know that if you have the presence of an observer there, maybe the workers are acting in a different way as normal. So maybe they are trying to be more productive, or maybe they are just distracted. So one of the criticized is that maybe in some cases the presence of observer can interrupt the workflow. So in that way, previous studies have been tried to automate the work sampling technique, and it has been tried to do in a different ways. Some of them have been using sensor-based and video-based. Video-based technologies, or video-based is, most of you are familiar with that, but they are used. It requires single or multiple cameras for detecting and tracking the resources. So we need to have several cameras in the job site to record the workers, and then in the past they used to visualize all the records and try to categorize which kind of activities they were doing, if in that specific worker was doing production or preparation or which kind of activity. Nowadays these activities, this process can be more automated. It can be more automatized, and some researchers are using machine learning for they make the video, and then with machine learning they classified the categories of the activities. Another kind of studies, they are using sensor-based technologies to identify the movement of the workers. So now it's not just I can see that he's making he's painting or he's applying the mortar. Now with the sensors, of the kind of movements that they are doing, they can say which kind of activity they are doing. So those images here are from one of the researchers that were working in our department. Emil Jacobsen is a former PhD of our department, and Johan Teiser is a quite popular researcher in the use of sensor-based technologies for identify activities in construction processes. So here you can see in the images that this is the kind of study that Emil did. It was about using sensor, and with the sensor in the body of the workers, that he tried to identify which are the posture and the motion, and with the accelerometers of the sensors, he tries to say, okay, if he's doing like this, he's painting, but if his hand is moving like this, probably he's just walking. Okay, so this is what they are trying to do when they are use sensor-based technologies. But obviously, it has a lot of limitations because it depends of the kind of activity that they are doing. The moves of the hands and the body is going to be different. So it requires to collect a lot of data and to feed the algorithm that they are using in the machine learning for identify which kind of activity they are doing. And another study, they use it indoor positioning like Bluetooth or low or BLE, like Bluetooth low energy, for estimate pressure indices. And that was like our starting point. Okay, it's very difficult to make records of the job site because we need to have cameras. It's also very difficult to have sensors in all the workers. And also, even if we have sensors in all the workers, it's going to be very difficult because we need to say to the algorithm which kind of this movement means, and then they need to identify which are the kind of activities they are doing if the accelerometer of the sensor is making this kind of activity. So we said, okay, indoor positioning is something that can help us to understand or to automate the work sampling technique. And this is something that they started in the group of Olli Sepanen in Aalto in Finland, and they started to use indoor positioning systems. And they believe that the present index can provide a kind of information. And it's like they believe that the more you are in a specific place, the more it's more likely that you are doing this kind of activity. It means that the more likely that if you are in a production workspace, if you are inside of the building, it's more likely that you are doing value-added activities than if you aren't. And it's obviously thinking in that way because, for example, if we are in our office or if we are in our workplace, we are more likely to do value-adding activities, which can be read or which can be writing papers or whatever that you feel as productive. But if you are not in that place, obviously, if you are in the corridor or in the bathroom, obviously you are going to do other kind of activities that are not going to be adding value activities. So they have two basic assumptions that they said. Presence is obviously not enough to say that they are doing value activities in a specific place, but it can be assumed. And also, if work gets interrupted, these interruptions are mostly non-value adding activities. It means if you are in a work production workspace, and if you are interrupted, probably it's going to be interrupted for something that is not adding value because someone wants to talk with you or someone needs something that is not going to continue, is going to provide you to continue working. And then value-added activities are likely taking place in the production workplace. Obviously, you can be in your workplace and you can do other kind of activities. You can just thinking and you can just be talking, but it's more likely that you are going to be productive if you are inside of the building in a specific place where you're supposed to work, that you are in another areas. So that were also our assumptions that, okay, let's think in position instead of trying to use the movements of the body to automate the work sampling technique. And this group of people from Alto continue this idea that let's see, let's combine several kind of data that they are coming from video base. Okay, they decided to continue recording, but also they try to identify also the position. So they used these head-mounted cameras and combine the video with the position. And they say, okay, now we can record the workers, see what they are doing, and also to identify where they are. And this is, you can see here the thesis of Christopher Horst, that was a researcher there in Aalto, Finland. And then, but they did a very detailed data collection that they were follow as a specific worker during their work, during his working hours, and try to see, okay, let's record that specific worker and try to see what he's doing in an entire day. So this is taking a lot of time. It's a lot of consuming time. It's very consuming time. And then they classified the activities that they were doing in those different kind of activities. And here we can see 4 kind of colors: green, blue, red, and gray, and they classify into value. As you can see here, green bars is value adding, blue is red is not adding value, and gray it was unclassified activities. Okay, so they were trying to combine video based and also position. And this is that was our starting point. And how, if we try, how we can identify the share of time spent on value-adding activities or the distribution of workers' activities using location-based data. And here I placed the image of a smartwatch because this is the device that we wanted to use for measuring the distribution of workers' times. And for understanding this, I'm talking too much now, Dayana. I can see that it's 50 minutes already. But well,
No, Chris, 50, 50, 50,
okay.
don't worry.
Okay. No, but in the record it's already 50.
No, don't worry. We are super good.
Okay. So for understanding this, we need to have in mind 3 important concepts. I'm making a mix of a lot of things because we need to have a lot of previous information or background for understanding the study. So we need to understand which is sensor-based technologies, which is location-based technologies, and wearable sensors. I know that most of you are familiar with those terms, but yes, have a look at this. So sensor-based technologies, you are familiar with this. When we are talking in the cyber physical system, sensors are a device that sense. The proper word says what it's doing. Sense. The sensors can feel, can see, can hear, can smell, can taste. Sensors as our own sensors. So a sensor is a device that detects something from the physical environment and transfer that information that it put into data. So this is what is a sensor. It's a device that sense and transfer that input into data. And then obviously you can move to the cyber, to the physical environment, but this is not what we are going to talk today. You have been talking about this in previous lessons about the digital twins, how you can transform this, you can move in those other environments. Okay, so this is a sensor. And then we need to understand what is a location-based sensor. There are different types of sensors, and some of more famous location-based sensor or more popular, the GPS system, which is the global positioning system. Then we have the RFID, which is the radio frequency identification. Then we have the geographic information system. All of them, they have in common that they collect spatial information. So they collect information about the place, the specific place. And then there are several kinds of location-based technologies. As I mentioned, we have the GPS, and also we have others like Zigbee, ultrasound. The difference between all those kind of sensor-based technology is the accuracy. And obviously, it depends what you are looking for and what is your interest that you are going to use one kind of a sensor or another. If you want to have a very precision, a very high accuracy, you are going to go to ultrasound or Zigbee. But in our case, we are trying to identify where are the workers. So for us, it's not important to see if they are 1 centimeters here or in another place. It's just something more. It can be in a frame of 1 meter or something. The accuracy can be something like this. And then continue talking about the location sensor-based technology. We have the most famous concept, which is global. Here I can see global navigation satellite system, which is also we use the acronym GNSS, and it's a network of satellites. Generally, we make the mistake of saying GPS as all the of the navigation system, but GPS is one specific constellation, but the concept that cover all of them is GNSS, which is the network of satellites, and it depends who is the owner of those satellites, that there are several names. For example, the famous GPS is from the US, but here in Europe, we have also the Galileo, and also the Russians, they have their own satellites, which is the GLONASS. And well, GPS is a global position system, and the difference with the other is that it's a network of satellites, and there are several constellations. Okay, so we are going to use a global navigation satellite system to identify the position of the workers. And then another, I said that we need to have in mind 3 concepts, which is sensor, which is location-based technology, and now wearable sensors. Wearable is it only means with the kind of platform, the kind of platform that we are using for moving our sensors. The sensor can be placed in the job site in different platforms. It can be stationary, that you place in a specific place. It can be handed, it can be equipment mounted, wearable, it can be in a troller. Also, it can be, as you are very used to use with unmanaged aerial vehicles, like in drones. So it doesn't matter whereas the platform that you are using. What is important is the sensor that you are using for collecting this data, right? You are very familiar with this. So in this case, we are going to use a wearable, because wearable is something that is you can wear, so it's attached to the body, and it can have, and the kind of sensor that you can place, it can be any. But in this case, we are going to use a wearable device. This is a smartwatch, and the sensor that the smartwatch has a lot of sensors, but the kind of sensor that we used it was the GNSS. So it's just for understanding the location of the workers. So, and before starting doing our research, we said, okay, but how other people or other researchers have used it, or have used smartwatches or wrist-worn sensors in the construction industry. And what we saw is that in most of the cases, we try to classify it into categories of studies. And we saw that most of the people that used wearable devices in construction sector, it was for 3 main purposes. It was for activity recognition, for health and safety. Also, they made this study. So health and safety is also for understanding how the workers feel when they are in the job site, but it's not psychological safety. It's how is the heart rate, how is their blood, so they can investigate also the workers' physical status. And what we saw is that in most of the cases, when they are trained, we used wearable devices for activity recognition. It was very limited, and in most of the cases, it was in a laboratory. So in most of the cases, they used one worker, or the data from one worker in a very controlled scenario, and they replicate the kind of activities that a normal worker is doing in the job site. So they don't have a large sample for in their studies. So what we say is, okay, let's try to use smartwatches and the sensor of the smartwatches to automate the work sampling technique. And we developed a protocol for making the work sampling technique using smartwatches. The first thing, the protocol have those main steps, which are those 6 that you can see here. This study preparation, the setup of the smartwatches, then the gathering the data, then we need to store the data and transfer, we need to clean, and we need to analyze. And before moving to how it was the process of transforming the data collected from the smartwatches to information, I want to show you this pyramid that probably you are familiar with that, but it's necessary to understand that this is in this pyramid we transform data into when we connect the data, we have information, and then when we connect this kind of information with our previous background, we have the knowledge, and then if we can predict or we can make more further analysis, we have our wisdom. So it's important because sometimes the people say, okay, if we place if we use a smartwatches in the workers, we are going to understand where they are. Okay, yes. At the end, you are going to have this kind of information, but it is not going to be that simple as you can imagine. So let's move how we move. We move from data to knowledge. So data. You know what is data. All of you are collecting data. Data are figures, signals, individual facts, and then when we add context, we transform this data into information, and then when we add meaning, we transform this information into knowledge, right? So, and those figures or images are very famous when we want to explain this pyramid that data are those points, information is when we classify it, or when we group the data, and then knowledge is when we make the right connections, and then the wisdom is when we add the context, and then we have what we can see here, the conspiracy theories is when you are connecting the wrong points. So you have the data and you are using the data in a wrong way. Okay, so continue with the setup of the study. So those are the 6 steps that I mentioned before, and we made a case study in a large job site. Most of the studies that we did in Denmark, or I did in Denmark, are in renovation project because as Denmark is a Scandinavian country, most of the construction activities that are happening there is renovation because for several reasons. It's because they believe that it's not necessary to continue building new products because we have a big stock of buildings. So maybe it's more interesting to renovate what we already have. So in order to produce more, before we need to renovate the existing stock, and also because those buildings were built in a states in the world when they needed to build in a very fast way. They are from the ends of the 60s, at the end of the worldwide war. So they were built in a very fast way, and now they are not more efficient in the sense of that they are not energy efficient. So we need to renovate that, and this is one of the biggest deal of all the European buildings, that we have a old stock of buildings that they need to be renovated in the next couple of years because it's a mandatory that a new law that is coming from the from the EU. So this case study is a job site from the 60s, and you can see here a photo before the renovation. Is a typical area, is a typical residence project where most of the buildings have around 5 or 6 stories, and you can see that in the phase that we were. Let me see if I'm going to select here. In the time that we were doing the data collection, they were doing the activities of renovation in these areas. And we can classify that they were doing the production. In this case, production is what they are doing, renovation. They are not making something new, but they are transforming the existing building. Okay, so how was the research design? The first activity is we clarifying the workspace categories. Then we made the data collection, data extraction, cleaning, and analysis, as we said. And here in this research design, you can see was, okay, first we clarified the workspace category. So moving back to the job site. So where are the value-adding activities are going to happen in those specific buildings? Okay, value-adding is going to happen inside the buildings, right? And for example, if they're around the buildings, probably they are doing preparation, but if they are very far from the buildings, they are going to do other kind of activities. Then we need to collect the data. For collecting the data, we use the smartwatches, specific the brand, the Garmin brand. Then we need to transform this data from the Garmins. We need to extract what is the kind of information that we're collecting from the Garmins. We are going to see later. Then we need to clean the data, and then we need to analyze, and also we need to visualize this data. I'm going to go into detail of each step. So we classified the job site into 3 categories, but it can be classified in so many but it was the first study, so we decided that just 3 categories was enough, but then we classified it into others. So we classify it into production, which are the buildings under renovation. Then we have the preparation, which are the surroundings, and then the transportation, which are the areas that are around the buildings. So now we can say that if a worker is in the production, they are likely to do production activities. If they are in the preparation, they are more likely to do preparation, because it's not possible to do production if you are not in the building that you need to renovate. And continue that idea. Then the data collection. For the data collection, we use this kind of smartwatches, and we have several smartwatches. We have 20 smartwatches, but in this case, we only use 10 smartwatches. So we need to deliver the smartwatch. We selected the carpenter trade because most of those renovation activities are made by carpenters. Then we deliver the smartwatch to the carpenters, and the data collection was 7 days. And we called every day from day 1 to day 7, and the working hours from 7 to 3:30, and then the 10 carpenters were involved in the study. And then this is the number of data sets. This is our data set, and each number here represents the number of data points. Each data point has, let me see, we have here the information. Probably they will say, well, each data points have the coordinates of each position, like the altitude, longitude, and I don't remember. Okay, but it's okay. Okay, so it has the point it means that in this day, the day 1 smartwatch 1 collected 2,549 points. So we have this number of coordinates in the job site. Then we need to create a user account for each smartwatch. So it's because it's not that just we provide this with the smartwatch and then we are going to have the data. We need to create a user, and then we are going to the we need to also to prepare to add information to every smartwatch. We need to give specific information about the worker that is going to use that smartwatch, because it's not the same that I'm using a smartwatch of my father, because my wife, my age is different, so the movements is going to be different. And then all those information are added to the system. We are using the Garmin Connect app that they have, and it's very easy to track because you can visualize all the smartwatches and you can see all the activities that are recorded. So what we did is we delivered the smartwatch at the beginning of the day at 6, and then we pick it at the end of the day, and then we move this data to the computer by a cable, a wire USB, and then we update the system with the information. For that, we need to also have another application, and then when we extracted the data from the app, let me see. Okay, this is how it can see. Those are Hoskill is the name of the city where we're doing the data collection, and here you can see the days of the data collection, and for example, the distance and the time that they were working. Here, this is how we can see the information in the system. We can see the job site, and this are the areas where the worker. Let me see if I can play. Maybe no. Well, it's okay. The video is not working. Then what we can, if we go here and we can see that in that specific day, for example, in June 2022, that worker spent 8 hours of time, 8 hours and a half, and they walked 15 kilometers. So think a lot that in one day, one worker walked 15 kilometers, which is quite a lot. If also you need to walk because it can be just a walk, just walking. Then we need to export the data we export in this kind of format in GPX. Then we need to transform this into a CSV file. And then now what we have from the Garmin is this. This is the data that is coming from the Garmin. We have the latitude, the longitude, and the altitude. And then we can see, also we can collect the heart rate, but this is not the case. So we weren't interested to collect this kind of information. So we didn't add to our study. And here is what you can see. Every point means that we have a timestamp. So it was collected at 5 in the morning of that day. It was collected this coordinate. And at the end, we are going to have, as I mentioned before, around 2,000 points every day. So this is the data. This is the kind of information that we are collecting from the data. And then we make some kind of aggregation and cleaning, and we said if a worker is moving faster than 0.5 meters by second, probably it's because we have an error, so we remove that point, that sequence of points from our data, and in order to have our data as clean as possible. And then what we can see here is, for example, this is the data for the smartwatch one, and we can see here in the x-axis we can see the working hours from 7 to 3, and we can see the distance that they were walking. So you can see that, for example, the largest distance was at the 10:15, and they walked around 1 kilometer. So this is now we are the distance obviously is measured by the distance between 2 points with the 2 coordinates, right? And then we can see which is the total travel distance per day and also the total travel distance per worker. And we can see how much how is the distance that they are travel at the end of the day. So we can see that, for example, some workers are walking more than others, and it makes a lot of sense because it depends on the kind of activities that they are doing. They need to walk more or not, and also not only the kind of activity, also the kind of role. Probably the worker that is in charge of the transportation activities needs to work more than the worker that needs to also do the productive activities, right? So this is now we have transformed this data, those data points into information. Now we have what is the total travel distance that they walk at the end of the day. And now we are not just interested to understand the distance that they are traveling, but also where they were, right? And this is what we can see. This is the job site. If you remember, these squares are the buildings, and these are all those points in red are each data point that the smartwatch collected. And now we wanted to see how much of those data points are in each specific workspace, in the production, in the preparation, or in the transportation. For that, we developed a Python program, and we said, okay, this area, this square is production. This square here is preparation. So if the point is here, he's doing production activities. Obviously, we are assuming things, but we just wanted to say, okay, where they were. Know if they are doing activities or which kind of, where they were. Just to understand where. Okay, so now what we can see is that all those data points that we have around in that day, for example, we have, let me see, to pick the pointer, we have 3,000 points, and we try to classify it. So into production, preparation, and transport, we can see that worker, this is all the points of that on one specific worker, they spend 60% of their time in preparation in the yellow area, and that other worker spend the opposite. He spent 60 or 54% of his time in production. And you can see here that it makes a lot of sense because you can see that worker was working a lot in the job site. And here that worker spent most of the time between the two buildings. So they were more likely to be in production spaces that they was working a lot. So what we made is, okay, all the smartwatches, let's try to understand how much time they spend in the industry categories that we define at the beginning of the study. We can see SW means smartwatch 1, 3, 5, and how they are spending their time in the different categories. So that workers spend around 60%, 66% of their time preparation in comparison with these that they spend 55% of their time in production activity. So now we're almost close to automate the work sampling technique. Obviously, we cannot say which kind of activities they were doing, but we knew where they were. And now we can compare the distribution of the workers. Like you can see here, the total, the 100% of the observations and the days, and we can see the difference between the workers, the workers that was wearing the smartwatch 5 with the smartwatch 6. So you can see here that there are several differences between the kind of workers. So this worker that you can see here is spending more time in production, and that worker here is spending most of his time. His average time is around 68, 68, and this 77 in production. So what we can see here is that we're trying to make correlations, like the worker that is walking the most, like this worker, for example, that is working in a day 1, 13 kilometers, 14 kilometers, 10 kilometers, he's spending around 20 or 30% of his time in production workspaces. In comparison with that people, or with that worker that is only walking 3, 5, or 4 kilometers in the day, he's spending 80% of their time in production workspaces, which makes a lot of sense. If you don't need to walk a lot, probably you are spending more time in production, as here. And how we as a construction managers are going to use this information. This can be seen in different ways. Obviously, it depends of the nature of the activities that they were doing, because some of them they were in charge of transportation activities, but in other cases, the job site distribution impacted in how much time they needed to spend in moving around the job site. So having a proper job site or a proper job site distribution or layout of the job site impacted on their time, on their production time. So we as a site manager, we can use this information to see, okay, if my worker is working a lot, why is the reason? Is because the nature of the activity, or because we planned the job site in an improper way and they need to transport a lot from the material storage space to the production workspace. So what we can see is that those correlation, that obviously correlation doesn't mean causality, but you can see that the more they walk, right, the more they walk, here you can see the people that they work around 15 kilometers is the people that spend the less time in production workspaces. And obviously it's the same, the more they walk, the more time that they spend in preparation activities. So this is information. And how we are going to transform this information into knowledge. We are going to see that, for example, that worker that was wearing the smartwatch number 5, that spent 66% of his time in preparation activities. This is how he spent his day. So he was moving a lot. And he was, in this case, he was in charge of installing the windows from the scaffolding. And in this case, that worker that has a very specific activity that was installing the membrane or a membrane on the roof of the building. He spent 68, around 70% of his time in production activities. So according to the nature of the activities, it impacted on the time that they spend in production or in preparation activities. Also, I don't have here another example, but it was clear also that we used this information for compared to the schedule, the kind of activities that they have planned and the kind of activities that they were doing. So it was clear for us to see that the workers that they didn't have a specific activity, or the work package that they need to do in a specific day wasn't clear defined, they spend more time walking because they needed to look for information, they needed to look for the material, so they spend more time on preparation than the people that have a very specific activity that they need to focus on that activity and go there and do their productivity activity. So this is another example, another study that I don't have here, but how having a clear work package defined in their schedule helped us to improve or to use their time in a more efficient way, because they needed to look for information material or making preparation activities or activities that do not add value. So here I can see that it's a clear relationship, but the workers that are working more are more likely to spend less time doing production activities. So we as a site managers, we can think the job sites in a more efficient way in order that they need to work less. And here is we make 2 rounds, one in November of 2021 and another round in May of 2022. And we can see here that in average, in that period of the year, they walked around 9 kilometers and they spent around 46% of their time. Then they were in a second stage of the job site of the renovation. And the thing is that the material storage area, it was in the same place at the beginning at the phase 1 and the phase 2, and they needed to work much more in the second phase because the buildings were farther from the storage, so they need to walk more. And you can see here that in general they spent around 11 kilometers walking, and consequence of that, they spend less time in production workspaces, and probably they spend less time doing production adding value activities. So this is how the job site distribution impacted also in the distribution of workers' time. And here is a way as how we try to automate the work sampling technique. We are not telling that they are spending 30% of their time in value-adding activities, but this is the maximum number that they can spend in value-adding activities, because it's the maximum time that they were on the place that they need to do the value-adding activities. But obviously, they were doing non-adding value activities. So it's a approximation about the maximum value of maximum quantity of time that they spend on value-adding activities. And here, well, we can make a lot of analysis regarding group it into work according to workers, or we can group it regarding to the days. And you can see here, this is in the round 1. They were closer to the storage, and here they were distributed in other buildings, so they needed to walk more. So this is how we transform the data points collected from the sensor-based technology. We transform in information when we collected the distance, and when we then we grouped the points into specific workspaces, and then we transform into knowledge when we saw that how the job site distribution impacted on the time that they spend in their production activities. And then the wisdom is how we can change our plans, how we can change the way that we prepare the job site in order to have a job site that is easier for workers, or they don't need to spend so much time doing those non-adding value activities. And just to end here, obviously, we can move to the last part, which is the conspiracy theory. Like, is okay, a lot of people, they were asking, okay, but you are tracking workers because you are using smart watches, you are trying to see what's in my breaks, what I'm doing every time. Okay, this is not like this. That wasn't the purpose. There were a lot of concerns about ethical issues, but we were interested to see what they are doing. We were trying to understand how site managers can plan job site in a more efficient way to help workers to do a more efficient process. And obviously, I can show you here that this is all the data points of our workers in a working day. And here there were a baker, so obviously they moved to the job site to buy a bread for the lunch, but this is okay. We are not trying to make the workers a robot that they always need to be in the job site. We want to use this kind of information or this kind of data to make the job site or the construction process more efficient. But this is not. This is the last. This is thinking that we are trying to track workers. This is not like this. This is for site managers to be more efficient. And this is how we move it from data to information to knowledge to wisdom, and we didn't move it. We didn't move to conspiracy theory. So that was an example about how we use it, wearable sensors, wearable devices, using the sensor base to try to optimize the work sampling technique.